Hello everyone, today I want to talk about the preparation of a Grignard's reagent. We use the Grignard's reagent to reduce a ketone or an aldehyde and add something to it other than just a hydrogen, which we would get through sodium borohydride or aluminum hydride, I believe is what it is, AlH4, right? So we want to add something to it, we use the Grignard's reagent. So how do we prepare a Grignard's reagent? Well, you'll see how we use the Grignard's reagent in another video, but today I just specifically want to talk about, okay, when we're in lab and we want to make the Grignard's reagent, if we maybe don't have it, how do we do that? It's quite simple. You need an alkyl halide of some sort, just a place on the molecule where there's a carbon-halogen bond. That's where this will occur. So our reactants is going to be, of course, that carbon-halogen bond. Magnesium metal needs to be a reagent here, so we're going to just drop in magnesium metal, and as we'll see, it will follow this mechanism. So this bond is going to undergo homolytic bond cleavage. If it could go, my marker's dying. But instead of the halogen taking on a radical, it's going to form a bond with one of magnesium's electrons. And what that's going to form is it's going to form a magnesium halogen bond, and carbon will become a radical. Magnesium still has an electron here, so what it will do is it's like, carbon, I know you really don't like having an electron, right? Because an electron on carbon, carbon's not a very electronegative atom. It doesn't really like having an extra electron just kind of chilling. It'd rather share it. And usually that will help it fill its octet. So we have the bond form through fishhook arrows, and then we get this here, which is carbon bound to magnesium bound to halogen. Now when you look at this in your textbook, it will probably be simplified with the carbon halogen bond with magnesium, and it kind of butts its way in between and separates the two, the carbon and the halogen. And that's good if you can memorize that, but in my opinion, I hate just seeing something in a textbook and not really being able to know what's going on, really. So I like to learn the mechanism, and hopefully you too as well. I just wanted to go over why the Grignard's reagent works, looking at the product that it forms, this Grignard's reagent. We have to look at the bond polarities here to understand its properties. So let's look at the carbon-magnesium bond. We know that's about roughly 0.7 Paulings between this here, if it was just carbon-magnesium. But we have an induction. So you may see my super illegal 2 dipole moment drawing. I just wanted to emphasize that magnesium, some of that electron density that's here is getting pulled by the halogen, making this even more polar than 0.7 Paulings, which practically makes this molecule ionic. So we're just going to draw a negative and positive charge. It is literally borderline on the 1.7 threshold that we have for ionic compounds. Okay, pretty simple. Hopefully that makes sense to you. Just remember, it's such a polar bond because of the induction and the fact that it's a carbon-magnesium bond that it's basically ionic. And that's what helps carbon act as a very, very, very strong base. Such a strong base, such a strong nucleophile. When it attacks a ketone or an aldehyde, it just, like that, it's crazy. Because carbon hates a negative charge, it's not electronegative. Okay, moving on. We have this example here that I'd like to show you. You can try it on your own. I want you to draw the full mechanism. So take a little second to do that on a piece of paper. You can pause the video. Okay, so we know that the first part is that homolytic bond cleavage. Drew my fish hook weird. Okay, so we get a radical benzyl group, and we get our magnesium bromide. But not quite magnesium bromide yet, because it hasn't lost that other electron, and then these electrons electrons come together to form a bond. And that forms this with a negative charge, basically a negative charge. It is a covalent bond, but it is quite electronegative. And magnesium bromide with the positive charge. So that's your products there. You have very basic benzyl group that is just ready to attack right there. So hopefully you learned how to prepare Grignard's reagents. I'll also be showing you guys in another video it in action, how the Grignard actually attacks. I'm sure you know how it works, but in case you want to learn how it works from my perspective, take a look. I also recommend Chad's Prep. He has some good videos on these alcohol reactions. So have a good day, everyone.